happy and honored to be here as well. My name is Gilles Eggenspieler, and I'm the director of the academic program at Ansys. Okay, that's a very good question. So when you think about Ansys, we do simulation, right? So we have a lot of different tools that can help students complete their project, do their research, and also increase what they know about simulation and put those skills into their resume to find a great job. So when I think about what can be done to foster that is first thing when we talk about classes, making sure that the student have all the resources to learn simulation, understand how it works into the design and engineering process. So that's what we do with the university. We both have material we provide to the university to help train the student, support them when they have questions, and also great professors that teach simulation use some of our material to actually train the students. So it's all about it's not only about the licenses and access to the tool, it's access to the tool and also all the key resources for the student to train and learn the tool and how it works in engineering, and also making sure we provide them support when they have questions, when they're working on a project. Project can be a class project, but it can also be a research project. Yeah, so I will talk first generally about the academic program at Ansys. We support or work with 2,600 universities worldwide. We sponsor more than 1,600 student team, and we have more than 600 classes or courses available online. It is completely no cost, freely available to everyone. So that gives you a little idea of the scope and the scale of what we do. But I also want to make sure you understand where we're going and where we think the future is. It's a little bit along the line of what I just said. It's not only about access to our licenses, because our products, some of them they're not always easy to use. So we focus on easy access to the product and the licenses, so students have access to Ansys, easy access to resource material for the student to learn Ansys. Some of them is shared with the professor and professor use them in class, but we also want to make sure that students can learn Ansys on their own or look at different modules if they're interested. So it's both the class, but they also can self-learn. We also have a great forum that is monitored by our technical expert, so students can ask questions if they get stuck, if they have a question on a specific engineering application, or how can simulation help them in their engineering challenge. And the last part we have also, which we think is very important, is a certification process. So students can actually take a certification exam, get certified, they can add this skill to their resume, they can add a certification badge, for example, platforms like LinkedIn, and that helps them find a job. So we really want to work on the full spectrum, which goes from access to the tools, training, support, and certification. Yeah, so that's very important. So if you look, we're just talking about that with a professor 5 minutes ago. If you look at 10, 15 years ago, you still had very big silo. You had mechanical engineering, you had EE, electrical, you had biomedical, you had computer science, and etc. And those were very siloed, and you didn't have a lot of cross-function. But now think about any mechanical application now has a sensor in it. So the walls between those different specialities are basically coming down. So it's very important to do things like interdisciplinary multi-physics simulation. Not only fluid dynamic, not only mechanical, not only electromagnetic simulation, but actually starting to couple all those three. We hear in talking about electronic cooling. Obviously, electronic cooling, the heat source comes from an electronic type of application. The cooling is more a mechanical type of application, passive cooling or active cooling. So you can see how those two merges. You can think about, you gave the good example of biomedical. So biomedical science like imaging, because they're patient specific. So it's imaging on someone's heart that we're going to turn into a simulation tool. Then it can be, I'm just talking about again a heart application or cardiac valve. It can be fluid structure simulation for the blood. It can be mechanical simulation for the valve and the behavior of the aorta, for example. So you're talking about fluid So you're talking imaging, fluid structure interaction as well. So already there, it's very multidisciplinary. Then we can think about, hey, how many I want to do a lot of simulation and know what if scenario, what will happen to this heart under what condition. So you do a lot of simulation that you can actually use. You'll have a lot of data that you can use to train an ML system. So we're entering into the AI type of approach. So even with just a simulation of a heart, we touch a lot of different technology. Yes. So there's our key priority, and here is why we have an Ansys academic program. It is because all the companies we work with need more students that are trained in simulation. Companies really value having students they can hire and that have simulation skills in their resume. So the message for the student is, once you get a job, it's already too late to try new things because you get a lot of responsibility, you get a project to work on. So use your time at university to learn key technology. Those key technology can be 3D printing, it can be AI, ML, but technology that really helps as well, and that's great to have on their resume, is simulation. So do not wait to work for a company to start learning simulation, but make sure undergrad, or if you're a grad student, you already learn the maximum of simulation you can. You put it as a skill on your resume, and that really helps get a better job and really helps boost the student's future career. Oh, we have a great collaboration here. Again, we're talking about an excellent class on thermal management and electronic cooling. That is, just this class is at 1,000 students per semester, but hopefully we can increase this collaboration to other topics. So other topics can be in the area of electrification, in the area of antenna design, for example. That's also a very important topic in the area of biomedical, as we talked about. So the idea would be to take the great model we have with this class and this collaboration and expand it to different applications and different departments.